gave us talks on that. Thank you. And I'm happy to welcome Jeff Underwood and Yuzi Lin of Facebook to talk to us about Map with AI, past, present, and future. And a quick note, in the other room will be ethical geography and humanitarian mapping. All right, Jeff and Yuzi.
Okay, great. Hi, I'm Jeff.
Hello, I'm Yunzi Lin.
Yeah, we're analysts at Facebook on the Facebook Maps team, and we're here to talk about Map with AI, past, present, and future. When I tell people I work on Facebook Maps, the first thing they always say is, wait, Facebook has maps? And it turns out we do. In over 200 different surfaces, there are maps. They're kind of just spread throughout all of our products, and you might see them in places like job listings, travel, commerce pages. They just add richness, even though it's not a core Facebook business. For the past about 2 or 3 years now, we've been entirely using OpenStreetMap for our base map. And so today I want to talk a little bit about how we got there and what we've done to support OSM since. So about 4 years ago, it was decided to replace our previous map provider, and we were looking at OpenStreetMap as a good alternative. But we did some analysis and found that in some parts of the world, it just wasn't really complete yet. There was almost no road network. There was very little. And it was decided that we couldn't really move on to it until we had addressed some of this, or it had improved itself. And at the same time, one of our engineers was playing around with using satellite imagery to generate roads using machine learning. And the higher ups were like, well, let's just give this a try and we'll see if we can use this to make mapping faster. And this, was only possible due to a couple advances at around that time. Commercial high-resolution satellite imagery became available and cheap. Our provider has been Maxar. Previously, it was Digital Globe before they were acquired. And also deep learning, a special type of machine learning that has multiple layers that allow us to actually do these predictions in the first place. Obviously, predicting roads from satellite imagery is a really difficult challenge. Even with good global imagery, you still can get varying qualities. Some places will have cloud cover even today. A road in one place may look like a riverbed. And you have tree cover in areas, you have buildings that are at angles that block the roads. So this was not an easy task to get started. We used hand-labeled training data and initially, and this is one of our early results in Thailand, really early on. You can see that although we predict the roads in white, they are incomplete and it's just not very usable. We did many rounds of training data and we ended up with a very good Thailand model, but a Thailand model doesn't work well for many parts of Africa or South America or anywhere else in the world. It just works well for Thailand and parts of Southeast Asia. So we took a different approach after that. And we used a global training data set using OSM itself, actually. So to augment our hand-drawn stuff, we took 1 million tile sample from all over the world, wherever there was OSM data, just randomly spread out. And this allowed us to have a truly global comprehensive model, and the results were pretty much night and day compared to our old model. You get some very stunning results. Here's a part of Ethiopia. You can see with the human eye, these roads are not very obvious, but our model manages to fill them in quite convincingly and quite completely. Here's another example in Nigeria. So once we had a decent model, we needed to actually start mapping with it. And at the time, we were using a fork of ID. We called it FB ID internally. And it was essentially rapid version 0, but it was a little different. It loaded static files. So we almost like JOSM. We had XMLs that had our machine learned data merged into them. And this had some strengths, actually. We could work on a file, save it locally or to our backend database, and then continue working on it and review it. And it never went live until we were sure it was ready to go. And that was a really good part of it. And we could add like tags for reviewing and then just pull those off at the end. So there's some real strengths, but it had some serious weaknesses as well. Because it's a static XML, the data was stale over time, and you get conflicts, and that can just ruin all your work. And since it loaded all the data in, like it was a square full of ML data, if you just missed something, it would still go live. And that was a big source of our complaints early on, is just data we just didn't see for whatever reason. And so we knew going forward, when we wanted to start to bring this public, that we needed to rethink some of this stuff. And that led us into making Rapid the way it is. It's fairly different, which Yunzi and I'll talk about for the present section.
Thank you, Jeff. Yeah, let's take a look at the present time of Map with AI. So the modern workflow of Map with AI, including 6 steps. The first one is using the machine learning model developed by our engineering team to do the road predictions. This prediction will be raster data. So we then have a post-processing step to convert this raster data into vector data. We're also able to detect the OSM data. So we merge these vectorized data with the OSM data. And the merged version will be shown in a tool called Rapid, also developed by our engineering team to do human editing. So once the human editing is done, those data will be submitted by the user who added the data to OSM. After that, a post-validation on live OSM will be performed as well. So let's take a look at a sample to see how this process exactly look like. So here is regions from Vietnam. So first, we start with the high resolution satellite imagery, and we make the prediction using the machine learning models. And you can see all these prediction will be raster data. And later on, we convert this raster data into vector data with our post-processing step. And since we're able to detect the OSM data, so we merge these vectorized data with OSM data. And the merged version would be the one that shows in Rapid. Rapid is an ML enhanced version of OSM ID editor. So in this tool that you can have access to our machine learning data and directly use that to do editing on OSM. And within this tool, you can see on the left panel, you actually got 2 options. So the first option, use this feature, and the second was ignore this feature. So use this feature means the data you selected will be submitted to OSM. And ignoring the feature or just simply not selecting the feature means the data would never be in OSM. And we also have the row hierarchy predictions. And those predictions will shows up on top of those 2 options, also on the left panel. Yeah. Here's a demo showing how the human editing process look like. So first, of course, you could turn on the rapid features. And you can see all these magenta color rows, they are the machine learning rows. And once you select the rows and choose to use this feature, you will see the color of the row change. And the tag of the row hierarchy will be attached to each row. But of course, if you think these row prediction, these hierarchy predictions of rows are not the most appropriate ones, you can manually change that in Rapid, just like how you do editing in normal ID editor. Other than Rapid, we also have the Map with AI plugins in JOSM. So the editing workflow is actually similar to how it is in Rapid. And as of today, we actually have almost the entire world having the map with AI data available. So this means that you can just simply jump into anywhere of the world that need to be mapped in either Rapids or using the Map with AI plugin and start do the editings using our machine learning data. Other than roads, we also do buildings because we know mapping roads take times, but mapping buildings even more intense and tedious. So we incorporate the machine learning building into our tool. Currently, we're using the Microsoft building dataset. The workflow of mapping buildings in Rapids is very similar to mapping roads. Same as roads, we have two options for you. Once you choose the use feature, the color of the building will be changed from magenta to others, and the tag of the building will be attached. And again, if you think the tagging of the building is not the most appropriate ones, you can also manually change that in Rapids, just like how you add it in ID editors. Next, please. So this is a heat map showing the usage of Rapid around the world. So we actually have Rapid being used all over the world and being used very intensively. And since the soft launch in May last year, we already have over 400K string sets submitted through Rapids. And you can see in the heat map there, one of the hotspot is Vietnam. That is where our current internal team is working at. And the next slide, we're showing the daily efforts of Vietnam. So here you can see how the daily effort accumulated for times of editing in Vietnam using using Map with AI data. So now we'll pass to Jeff to talk about the future of Map with AI.
Thanks, Yinzi. So launching very soon, like as soon as Monday, we will be releasing a new version of Rapid that has ArcGIS datasets integrated into it. And with these, we'll have a very rich and varied source of additional authoritative data that's ready to be imported into OSM. And beyond what Esri has collected, you can bring your own data. This is, we think, a great work path, great workflow to get your data into Rapid if that's something you're interested in doing. So it's a pretty simple onboarding process. If you have a data set, first, decide, does this add value to OSM? Like, is it bringing something new? Is the license compatible? And you can talk to us or Esri, and we can try to figure that out too. Esri's had a lot of experience sorting out licenses for these sorts of data sets. Then you need to prepare it. You need to decide, what is the tagging schema? How do you translate what you have into OSM tagging? Then publish it to the ArcGIS feature layer. There's an OSM wiki for these data sets you need to add it to, and then do some outreach to the community to let them know and review it. This is essentially just like an import workflow. In the review stage, we need time for the community to take a look and allow for some discussion and some changing if need be. And then finally, once that's done, we can release it and it'll become available in Rapid as a new layer you can add. So this is a new menu you'll see in Rapid now under the feature panel. Here we currently have about 12 data sets, I think, available. Some of them are address points, some of them are building footprints, but we're looking to add additional feature types and more data sets whenever we can, essentially. One of the great things about this is that aside from these being high quality, mostly hand-drawn buildings, they also have rich data. You see here, there's address information, there's height information, levels. So this is really good stuff to get into OSM, and we're really excited to have it. So beyond that, though, what's next? And this is all subject to change, just as a disclaimer. We will have new Esri data sets and new data types in the near future. Esri has another dozen or so, I think, candidate data sets. Like I said, this will be released next week, more than likely, for the final release. There are preview versions I can share if you're interested. We're looking to add confidence scores to Rapid. So what this means is that, different predictions have different confidence. There's different strengths to them. And so we are looking to add a slider of some sort, so you can say, hey, I just want like the absolute most confident roads, or maybe an area is a little weaker in predictions, so you could like add some more confidence there, and look at like weaker predictions because maybe they're still good data. So this way, I think you can kind of fine tune Rapid to work just the way you want it to. We're looking to release a new building layer by us at some point. So we've been doing machine learning on buildings for a little while now internally, and we're starting to get it to a pretty mature state. So don't have a timetable there, but we're looking to release in a few countries in the near future. Additionally, we're looking into other ways you can bring your own data sets. We think the ArcGIS Inline is a very simple and great workflow, but some people can't or don't want to do that. So we're also thinking about there's other avenues people can use to get their data into Rapid. Additionally, it looks like in the next half, we're going to be looking at how we can improve performance on ID and then therefore Rapid. It's very slow in urban areas, which is exactly where we're trying to add a lot of these data sets. And when you add additional data to them, like in our Rapid layers, it slows it even further. So we're looking at how to modernize and make ID just a little better. And of course, model improvements. We've been basically continuously improving our road model for the past 4 years now, and this will not end anytime soon. So this leads us with Map with AI today. You can visit our website, mapwith.ai, for some general information. If you're interested in working on Rapid, the source code is available. We've had a few people submit PRs, which is awesome. If you want this road data in export form, like to use it in QGIS, you can play with it at our GitHub there. You can download a full country. Rapid itself is mapwith.ai/rapid. The JOSM plugin is just Map with AI. And if you have any sort of feedback, we're on the OSM US Slack channel at mapwithai_feedback. And you can always reach out to us at osm@fb